This video describes the assembly of the components into the high voltage control enclosure. We'll be putting these components inside the high voltage control enclosure, which is a metal box, and it's good to lay out everything on two flat level surfaces before you begin your work. It's also good to have access to all of your tools and also to elevate the box so that it's easy to access from underneath. Here we can see our technician has elevated the box on two 2x4s so he can reach both underneath and from above as he tightens with the attachment hardware. Let's take a look at the layout of the components. We have our main contactor, the controller, the forward and reverse contactors, the auxiliary battery, our DC to DC converter, an electrical transformer. We have an isolated ground point, our DIN rail for connecting different components and fuses. At the top corner of the box, we have an input for the charge plug. And at the rear of the box, we have two fans. One will be an inlet fan and the other will be an exit fan to circulate air to cool the components. And finally, we'll install a reverse relay in the corner of the box. If you're building your high voltage enclosure for the very first time, you want to install the cable runs on the inside of the box. These cable runs help keep the cabling neat and organized as we install components inside the enclosure. The first component we're going to install is the charge plug. This is where the extension cord attaches to the high voltage control box to charge the vehicle. We want to put the ground tab in the up position as we mount the charge plug to the side of the control enclosure. The position of the control box in this video is from the rear to the front, so our view is from the back towards the front of the vehicle. So we'll line up the charge plug and tighten it into position. Next, we're going to install our isolated ground post, and part of the connection to this ground post is the chassis ground wire from the charger plug, so we'll do these both at the same time. We want to take off the large washer from the isolated ground post and put it underneath the control box. This is the attachment point on the bottom side of the box. The isolated ground post is a safety feature that keeps the AC ground separate from the ground used by the components inside the high voltage control box. Our next step is to install the DIN rail. The DIN rail is a mounting rack for several different types of components where we'll be connecting different wire terminations, there's a relay, and some fuses. But the DIN rail is a combination of these components that allows us to make other connections quickly and easily. We want to position the DIN rail with the relay towards the inside of the box. You can just fit it into place over its outline, but you'll see why the location of these components is important later on in the video. Remember, we're using our mounting hardware from the bottom up and the outside in of the box. This keeps the external edges of the control enclosure box as smooth as possible. This allows for a cleaner installation when we install the box into the vehicle. Our next component is the transformer. The transformer has two wires that connect to the DIN rail, and they're labeled. You'll see where they connect. The transformer will ultimately be mounted to the box with adhesive, and we'll not do this at this point. We'll just set it into place. But you can see that the wires need to be towards the center of the high voltage control enclosure, not the other way. They won't reach if you put them in the other position. So we'll set this into place now and be prepared to attach it later on in the assembly sequence. Our next component is the DC to DC converter. This is another component where we want to set it into place with its mounting connections towards the center of the control enclosure. And then we're going to attach the DC to DC converter with its mounting hardware through the bottom of the box, just like the other components. Our next part is the forward and reverse contactor setup. But before we mount this forward and reverse contactor subassembly to the box, we want to put in a diode. And these go on the lower connecting points on the ends of the forward and reverse contactors. You'll see a red side of the diode and a black side. The red side is the positive, so that goes on the positive tab on the bottom. And we want to put this diode on first before we mount it to the box because it's much easier to access. And then we have a diode for the other side of the forward and reverse contactor subassembly. The forward and reverse contactor subassembly is actually two contactors, one for forward and one for reverse, as we move the switch to go in forward or reverse on the vehicle. So with our diodes installed properly, positive to the positive tabs on the contactors, we'll insert the mounting hardware from the bottom up to attach the forward and reverse contactor to the control box.
Okay.
Our next step in the sequence is to install the main contactor. The main contactor is round, so it can fit either way, but you want to make sure you get it in the right position. The contactor has two main posts, positive A1 and negative A2. We want the negative A2 post in our assembly to be positioned towards the bottom or rear of the high voltage enclosure. Also note that we have a 12-volt side of the main contactor to energize the contactor. On this particular close-up, we see two black wires for the 12-volt side. So we want to line up our contactor in the high voltage enclosure with the minus A2 towards the rear of the box. It's marked on the bottom of the high voltage enclosure for both the minus A2 and positive A1. And you'll also see the 12-volt side marked towards the outer edge of the control enclosure. So once you have the main contactor in the right position, mount it into place with its attachment hardware. Next, we're going to install the motor controller. This is an important component that regulates the flow of electricity and voltage to the motor and controls the speed of our vehicle. There is a step included with this assembly that we want to show you. Your instructor may or may not have you do this, but that is to apply a heat transfer paste to the bottom of the controller so it efficiently transfers its heat to the bottom of the box. Not every assembly will include this process, but here's how it looks.
What we're going to do now is mount the Curtis controller to the heatsink, and the first thing we're going to use is the heatsink silicon heatsink compound. That's material that helps make a solid connection and transfers heat between the heatsink and the controller. To make the controllers their most efficient, we want to be able to take the heat away as efficiently as possible. So basically it's kind of a process of smoothing out the material, getting a nice clean even coat on all surfaces. And we're ready to mate the two halves together. So we'll place the Curtis onto the heatsink. Basically give it a good scoot around to seat it. And go ahead and apply the clamps and bolt everything together.
So we'll go back to our project with our controller. And the reason we may not need heat paste, transfer paste on our particular assembly is our entire high voltage enclosure is made out of metal. It's very efficient at transferring heat, and the controller is mounted right to this metal box, which essentially is a giant heat sink. We're also using active cooling fans to move air through the system. One of the cooling fans goes directly into the controller, flows air right over the controller. So it's very efficient already at transferring heat away from the controller. Our next component is the reverse relay. This goes in the corner of the control enclosure, and we want to make sure it's aligned with its terminals facing towards the controller. Our next step in the assembly sequence is to install the cooling fans. We have two fans. They're already wired together, and you'll notice that one fan has connections attached to it and the other is just wired in. We want the fan that has the just wired inside to be mounted near the controller. And if we take a close look at this fan, we're going to see that there's an arrow on the side of it that shows the direction of the airflow. We want the airflow for the controller side to flow directly towards the controller. So we want to make sure that that arrow is pointing inward on the fan that's mounted near the controller. So we'll mount our fan to the side of the box with the arrow pointing inward towards the controller and the wiring coming from the fan on the side towards the middle or towards the other fan. Make sure not to over tighten the hardware as you mount the fan, as the case itself is made out of plastic. So you can see from the alignment of our components after they're installed that the path of the airflow goes directly over the controller when the system is activated. This active air cooling keeps the controller at the proper operating temperature when being used under load. Now we can attach the fan on the other side of the control enclosure, and this fan will be mounted in the opposite position so the air flows out and exits the control enclosure. We also want the wiring on this fan to be towards the bottom of the control enclosure. So with this installation of the exit fan, we have completed the assembly of the high voltage control enclosure. And let's take a quick look now and overview what we've got installed in the box. We have our reverse relay. We have our main contactor, our controller, our forward and reverse contactors. We have our DC to DC converter, 12-volt transformer, our AC plug, our isolated ground, and our DIN rail. And then finally at the rear of the box we have our inward and outward cooling fans. The final component is the 12-volt auxiliary battery, and we'll be installing that as we do the wiring of the high voltage control enclosure. So we've installed a number of different components into the high voltage enclosure, and we'll see their interaction and wiring in a later video, but they will all connect together and connect with different parts of the vehicle via the high and low voltage harnesses and some of the dashboard instrumentation.